This video is about the actual data records of the three SPS2 files. That is, the X records, the S records, and the R records, but not the H records. Those header records contain geodesics, projections, filters, datums, and that sort of information. But that is not used for geometry update.
SPS2 consists of three files: the X file, the S file, and the R file. These are fixed format files, which means that values are always at the same character locations within the records. You may find that SPS2 records are also called card images, and the location of values within them is called card columns, because SPS format started in the days where actual paper cards were used for data. You really should look at the SPS standards online. Remember to search for SPS Revision 2. The first thing to do is to get an understanding of the interrelationships among the traces and the SPS2 files. A field trace header contains two values that also exist in the X file records. The X file records contain two values that exist in the S file records, and the X file records also contain two values that exist in the R file records. The two values in both the trace headers and the X records are the field record number and the field channel number, also called the field trace number. The two values in both the X records and the S records are the shot line number and the shot point number. The two values in both the X records and the R records are the receiver line number and the receiver point number. These are the Seismic Unix key names that are used for these values. The top two key names are quite well known. The next four keys are what I decided to use when I wrote SU Geom CSV. Seismic Unix has a limited number of keys, and these four keys were actually defined for 2D split spread situations. So they have some historical relationship to what they are used for in 3D. The S records and R records contain other values such as coordinates, elevations, and so on. Their key names appear at the bottom of this image. The numbers that appear here are the character locations on the records where the individual values are found. Note that I've made no effort to align the arrows in these diagrams with the actual character locations in the records. Notice here that the field channel numbers are actually specified as a range, and the receiver point numbers are specified as a corresponding range. The field channel and receiver point ranges define the segments which are recording a shot, as seen here. Remember, in another of my videos, I presented this image of a 3D survey. The shot location is the red dot, and the four blue lines near it are four segments of receivers which are recording that shot. Now, using a typical field record number of 71 and a typical channel number of 15, let's track through images of actual SPS2 files to find the geometry information. So, we begin by looking at the X records. We need to find field record number 71. At first glance, there does not appear to be the number 71 anywhere. But the field record numbers are between character locations 8 and 15, which is between these yellow lines. Remember that SPS2 files are fixed format, so things that look like one big number can actually be two or more smaller numbers. So now we can see field record number 71. In fact, there are four X records with that number. Over here on the X records is the field channel number range. The field channel number we want is 15, and 15 is in this range. Now, let's look at the receiver point number range over here. The field channel range is 13 to 24, and the receiver point range is 119 to 130. So field channel 15 is on receiver point number 121. Now we have the four values we needed from this X record. The first three values are just copied from their character locations on the X record. The fourth value is the receiver point number that we just computed. We now have the two values we need to find the correct S record, and the two values we need to find the correct R record. Knowing the character locations on the S records, it is easy to find the correct S record. So now we can get the shot coordinates, elevation, statics, and other values. And knowing the character locations on the R records, it is easy to find the correct R record. So now we can get the receiver coordinates, elevation, statics, and other values. Now that you know the interconnections between the field trace headers and the three SPS2 files, how do you use SU-geom-CSV to update those traces with their values? The sequence is similar to the interconnection order, except that SU-geom-CSV performs the updates from each SPS file separately. Using the field record number and field channel number, SU-geom-CSV finds the X record. It then updates the four keys. Remember, those four key values are the shot line and point numbers and the receiver line and point numbers. Using the shot line and point numbers that were put into trace headers from the X record, SU-geom-CSV finds the S record. It then updates the values from that S record into the appropriate trace header keys. Using the receiver line and point numbers that were put in the trace headers from the X record, SU-geom-CSV finds the R record. It then updates the values from that R record into the appropriate trace header keys. Note the null name. SPS2 R records contain a place for receiver depth, but Seismic Unix does not have a key for that value. The SPS2 options of SU-geom-CSV know that there is no key and use null so the value is not copied to the trace header. There are other values that exist on the SPS2 records which are not copied either. So that's it. We have gotten all the way from the two values in the trace header to all the values available in the data records of SPS2 files. This job uses SU-geom-CSV 3 times to perform geometry update from the 3 SPS2 files. Note that you can perform the update from the R file before the update from the S file, but the update from the X file must be first. Also, I want to point out here that sometimes you may have just S files and R files, but no X files. In this case, it is possible that a field recording system has already put the shot line and point numbers and receiver lines and point numbers into the trace headers. So you can just use the last two SU-geom-CSV updates. There is nothing that requires channel numbers to start at 1 or for channel ranges to be contiguous. And segments can have different amounts of channels. Segments for a shot are not required to have the same receiver point range. Generally, segments start at the same receiver point number and end on the same receiver point number, but not always. Segments for a shot are not required to be on neighboring receiver lines. What I mean here is that receiver line 500 might exist, but be deliberately not recorded for some shots because the survey designer wanted to record receiver lines that are further away in order to acquire different offsets or azimuths or fold coverage. Survey designers like to make those kinds of adjustments when it saves acquisition time and resources. In other words, when it saves money. The channel specification actually includes a channel increment value. On occasion, the channel increment will not be 1. This may be done, for instance, when recording from both a pressure geophone and a shear wave geophone. In that case, there are 2 channels at the same receiver line and point. If the pressure geophones are on the odd channel numbers and the shear wave geophones are on the even numbered channels, then this setup will give them the same receiver line and point numbers. Unfortunately, survey designers often like to use unnecessarily large values for line and point numbers. The seismic unit keys for shot line and point and receiver line and point can only hold integers with a maximum of 32,767. Another possible issue is that SPS2 files allow 2 decimal digits. If these decimal digits are non-zero, this is also trouble for Seismic Unix. Both these conditions require modification of the SPS2 files for use in Seismic Unix. This can be done using SU tool CSV. But it is also possible that an old field system did not produce X files and also did not update the trace headers with the shot line and point numbers and receiver line and point numbers. In fact, all you may have is an old 2D survey with observers notes or other non-SPS2 files. So now what? Well, this is where you need to use SU tool CSV and spreadsheets to define your geometry. Fortunately, your time watching this video was not wasted. You can use old observers notes to create the 3 SPS2 files. This is probably easiest using a spreadsheet program such as LibreOffice Calc. The primary concept to grasp for 2D surveys is that there is only one line number. So when you make the SPS2 files, you just need to put the same line number in 2 places on the X files and 1 place on the S records and 1 place on the R records. For a split spread 2D, you need to create 2 records in the X file for each field record number. These are receiver segments just like for 3D, but here there are only 2 segments for every shot. To create the S file and R file, you just need to create point numbers and associated coordinates, elevations, and other values. The coordinates can, of course, be based on simple increments of the receiver spacing. Again, a spreadsheet program can accomplish this quite easily. Alternatively, the demos directories of SU geom CSV and SU tool CSV contain an example of updating geometry for a 2D survey that only has observers nodes. The example does not use SPS2 files, but it is really the same sequence as for SPS2, except that it leaves out the line numbers since they are constant everywhere for a 2D line. It would be good for you to understand that example if you have many 2D surveys, since it is simpler than generating full SPS2 files.
Well, I guess you'd better look for my video about SU tool CSV.